separate modules are only interconnected via Profibus. So traditional hardwire safety circuit, you have a lot of wires going to contactors. They go across the machine all the way back traditionally to the PLC. What Siemens is doing is saying to end users, you can keep your existing hardwire architectures, but the next step or evolution is going to be to take this to this. This is OSI-bus. It's one of the most simple forms of bus. 2-wire connection back to a relay. The relay is inherently a smart relay, and that connects your Profibus back to the PLC. In this scenario, this is a safety PLC, so all the I/O that's off this PLC is fail-safe. The one that you saw over there is the same form factor, but it also has motion control built into it. Now, what this enables the end users and OEMs to do is to be able to take, like I said, safety at a module level, so in the case of drives, contactors, push buttons, bring that all together via a bus, it simplifies the connection to the PLC. Okay, this is Profinet or Profibus. We have both of them going back to the safety PLC, and both are safety rated category performance level. Now, to illustrate what I mean a little bit further is that when I say safety is at the module level, in the case here I want to put this machine into a service mode. You see that the motor reduces speed. The drive is actually controlling the motor, as you know, but it told the motor to go to that safety limited speed, not the PLC. So that means that there's an issue where communication is a problem here. The drive is in control of the axis, 100% in control. So the response time is a lot faster. In addition to that, if we're in a service function, you may want to have someone access this area. So the guard door is now released. If the load is close to the machine, it allows the maintenance personnel, albeit rudimentary, to enter into the zone up until that point where the area sensor picks up. All of this hardware and architecture, again, is at the module level. So as the end users are going around looking at OEMs and the latest and greatest of equipment, you have to think that it's much easier to connect up via this versus that. Okay? Now, what we're able to do within the drives is dictate how these motors will behave. You can completely disable the torque, you can limit the speed, or you can have a state at which if this guy was to come back out of the zone, I can start the machine back at the safe speed, but as soon as I put it back in manual, I'll stop the entire line because he's past the guardrail. What Siemens is doing as far as the machine control and the responses isn't new. What's new is that we're doing this within the drive and allowing the drive to dictate what its load is going to do. The second piece of this is to be able to take this entire architecture and do it wirelessly. So if you think about robotic cells, you think about large machines, you're able to take this to a zoned architecture. If this were 3 separate machines, when I hit the wireless access point with these 3 different machines, I'm now in control of that module. In a large converting line or a machine that may be, 100 yards long, I'm able to utilize this device to stop the entire line. The safety isn't here again, the safety is at the module level.
How was acceptance for that? Because I know when that was first being discussed about not safety itself over wireless, but safety interaction over wireless, there was a lot of trepidation. Is that changing yet? Are you seeing that, or is it still pretty much a lot of communication necessary?
What's changing is that we allow you to program how you want the machine to respond to issues related to wireless. Say, for instance, if your wireless network dropped out, you can either have the entire line e-stop, or you can have it just enunciate that this is no longer safe. The e-stop can be disabled on this device, and you have this screen, which more or less is emulating what you see up there on the touch panel. So you immediately know if there's a problem, with the machine and our network.
How is the market, though? I mean, people in the market, how are they reacting to wireless, using wireless as safety? Because I know there was some discussion that some of them didn't like the idea of safety being on the controller. They wanted a whole separate network. So this is going even a step further. So I'm just curious to know what the market perception is.
The market perception is a lot greater than it has been because the reliability of these buses is probably tenfold what it used to be, meaning that this is not an Ethernet-based network. The only thing you're going to find on there are devices that are deterministic and dedicated to your industrial automation. You're not going to have somebody's laptop talking on the same bus. As it pertains to wireless, the wireless devices are on that same bus. So multiple detection methods are done, meaning that at the wireless access point itself, or if there are communication issues along the bus. And again, you're not actually compromising safety because the safety is not here. Even if you weren't using wireless, it's there.
You mentioned earlier, I'm not the technical guy, so I'm glad you asked the question.
Right.
I know that Europe adapts to safety quicker and more pervasive than the U.S.
Right.
It's coming here. Are you still having resistance, or do people realize that they have to do safety too, and they're going to do it, or is it still you have to overcome objections?
The two things that we're trying to overcome is that a lot of manufacturers find it more economical to point guard machines or just to build barriers in front of the machines. And it compromises the operator's ability to interact with the machines. And what they're doing is the next step is to say, okay, well, if we do need to safely control machines, we know how to do this. They're becoming more and more informed that it's possible to do bus topology. The end users are the ones that have to demand the ease of installation for safety and to make the OEMs be able to do it economically. This is one method of doing it for both. Ease of installation, fewer number of components. The OEMs don't have to go out and buy a safety PLC. They can use just contactors. This is programmable. So you can connect up a PC directly to this device and program how you want it to respond. Delayed reaction, immediate, how you want the IO to interact between here. It's all programmed here. So it's more or less a la carte.
So it's an educational process.
It is.
As well as a financial decision.
It is. And the market is increasingly more competitive, meaning that we're seeing a lot of influx from OEMs that are developing machines in China. Okay? And the US OEMs have to take these machines and now move them overseas. Safety requirements, again, they're going to be on the performance level rating. They're going to expect these machines to be safe. There's a lot of what we call the M3 classification, meaning that a lot of operator interaction. There may only be half the machine that's actually automated. The other half, maybe the operator is actually doing things. In the case of one scenario, you guys see the machine sitting behind us, right? Well, what they've done is they've taken this device here and they've actually integrated it into the body of their machine. So if you look back here, this would be one such scenario where an operator is actually loading product into those blue trays, and this area sensor back here detects if anyone's in proximity of the machine here. So during their normal CIP process, clean in place, this actuates up and down. Okay? You don't want that happening if I happen to be standing right here. There's not a huge barrier going around this machine. Okay? There's one sensor. There's no safety PLC here. There's no network. It's all self-contained. On the front of this unit, drive.
So that just connects right into the drives. Like example.